right, so today we have Ciro Greco, co-founder and CEO at Bauplan, which you can find at bauplanlabs.com. By the way, that's Bauplan labs.com. Taglines are your data lakehouse built like software. Bauplan is a cloud-native lakehouse platform for engineering teams who treat data like software. And finally, shift pipelines without managing infrastructure using a specialized Python runtime. All right, so with that long-winded introduction, Ciro, welcome to the podcast.
Thank you. Thank you very much for having me.
And full disclosure for our listeners, I am an advisor to Bauplan, but I will represent you and I will grill Ciro hard on this podcast.
A beloved advisor. Yeah.
All right, so I think let me take a step back because you guys have written a lot of really interesting blog posts, and I'm going to try to structure this conversation in terms of some of the basic core values or principles you guys have, right? So the first one being that, software engineering rigor to data engineering, which, by the way, Ciro, I wrote a post about this 6 years ago. I never published. I just opened it, and it's still in a Google Doc.
I know it's been around for a long time, this idea, right?
Yeah. But it seems like you guys finally have put what, let's say, meat on the bones, right? So for our listeners, so what is this software engineering paradigm for data that you are trying to evangelize around?
Well, I think that the main idea has always been kind of like bringing, like it boils down to simplicity and to the ability of working with an easy way to reproduce your issues, to roll back, and to effectively get that. I think like the main thing about software is the best practices of software showed how to build massive machines with very large teams and scale them like indefinitely. And so they kind of like software engineers figured out a way to work all together on the same code base, on the same applications, keep that flow very productive and without sacrificing essentially the robustness of their applications. In software engineering, the robustness of an application is particularly important because that is literally the application that is going to probably make money if you are a software company. And in data, this has not been the case for a number of reasons. Mostly historical, I would say, but like even just the fact that, if you think about analytics, a lot of the applications in analytics up until just like, a few years ago was just like some reporting, some internal dashboarding and things like that, which I'm not saying they're not important, but it's a different, like there's stakes are lower if something breaks or something is not right or something goes down compared to this is my applications and I have, million of users depending on, and in my, my business depending on that. Now, I think like data is changing a lot in that sense. So is becoming like more and more important for companies to have like data that is up and running and it's very dependable and very robust. And a lot of those things like are just there as best practices, but the tooling is not quite there in data. And so Bauplan is an effort in making things very simple and very robust at the same time. I guess like that there has been some kind of like tension between these two things in data engineering in my experience. Like there's this kind of idea that for things to be robust, they need to be like very complicated.
Yeah. And also historically in data engineering, someone writing a pipeline historically would be touching many complex distributed systems, right? So I don't know, Kafka and then Spark and who knows what, right? So, but basically then if you try to map traditional software engineering to that, well, you have unit testing, integration testing, it starts becoming complicated, right? And functional.
Yeah.
So then, briefly briefly, what is the kind of Bauplan approach to overcoming some of this complexity that's inherent in data work? And by the way, data work by definition involves data and code, right? So,
So I think like that is the core problem is like if I have to, that was very clear to me when we were working like on machine learning systems, and we kind of like ended up here because Jacopo, Matti, and myself. So we've been together for a few years, and we worked like mostly on machine learning applications. And I think we kind of skipped that moment in history when like data science was essentially just like notebooks. We just went straight to, oh, this is going to be like a machine learning model that is embedded into a recommender system or a search engine, and so is effectively serving a software application. So the distance between your data heavy workload and your application for us personally has always been like very short. Like these two things are very tied together. And I don't think that is necessarily true for like data science at large. I think there has been like a long initial phase when we were kind of like, the job of a data scientist was to be very good at analyzing data, but not quite in understanding how a system should work in production. So the main difference is that data is an open system. So you do not control a good portion of what happens to you, because that is effectively what your users will do or what an external system will dump over your system and so on. Distributions will change. There are going to be spikes that are hard to predict and so on. So that's the first main difference. The second one is that data is very bulky when you do it at scale, and I think that ties back with some of the kind of like historical considerations. But like because it's bulky, serious data stuff cannot be done on your laptop. And this is a major difference. Like developing the tension between local and cloud in data adds some new layer of complexity. Like, oh, I work on a sample of data, but I don't know if the sample of data is actually representative of what happens in a production system. Oh, I have, I can use like pandas
or how can your laptop emulate your production environment? Like I said, that might involve multiple distributed systems.
Exactly. So the other thing is that like when things break on your laptop, they break for a very different reason why they break in the cloud. In the cloud, they break for weird reasons that often have to do with infrastructure, right? And the other thing is that it's very fragmented. Like it's kind of like the hard part of being a kind of a data platform person is that you're managing this complicated system that is both distributed and stateful and fragmented over different silos. So you have like application database, and then you have a lake, and then you have like a runtime that is going to move the data around but separated from the storage, so it's going to be like loosely coupled, and then you have like the warehouse, which is a more vertical system. So it's kind of messy. So what Bauplan is effectively a way to first of all include the data into your software engineering best practices. So, and that kind of like ties into this concept of Git for data that for us is very important. It's really a core portion of the platform. It's like the idea that when you can create instant branches of your data, and there's nothing you do. I think like the more abstract, like the more general way to describe this is like there is nothing you do on your data lake. In this case, Bauplan is specifically built for lakes for a number of reasons. But there's nothing you do on your data that you should not be able to bring along with your code. And there's nothing you do on your data that gets lost. You will always be able to kind of like travel back in time, reproduce something deterministically, understand exactly what is the commit change that of data changes in your lake and so on, which is something that is not something you take for granted in data. The second part is,
By the way, two quick questions there. One, you are very early on have hinted that, one of the challenges, of course, is scale.
right.
Scale of teams as well, right? So in software engineering. So in data, as data becomes important, scale of teams also matters. So address, whether this kind of Git for data approach works on data when there's 20 people working on that data. Secondly, I thought for some reason, Zero, there were those early generation systems, right? DVC, I think,
Mhm.
right? So what role do those play? So
So
scale
yeah,
of
yeah,
teams
yeah.
and then early systems.
So okay, scale of teams. So data team. So that is a complicated question because like data teams. So most companies that I saw in my life at a certain point kind of like consolidate some kind of central team.
Mhm.
Um, and scaling that team is pretty hard if you want to do that in harmony with the rest of the company. So you have like this team that manages the data. The team grows mostly because you'd never have enough data engineers because data infrastructure is so complicated. But ultimately, they're not really the people who need the data. Who needs the data is
Yeah. I mean, I
somebody
I I guess my
down the
question is
road,
around,
right?
you said, uh,
But what I was saying,
Git
like
for data, you're forking, five other people are forking
exactly.
it,
So
right?
in the Git for data situation, like in that situation, there's a couple of things you want to keep in mind. Like one is that if you have a system that is essentially a Git for data, and you lower the technical bar for a developer to be able to develop on the system in the cloud, that central team is now able to effectively give some independence to developers who work in the product team or in the data science team or in the application team without having to kind of like babysit the passage all the time because they're going to have like their own branches, their own environments where they do that securely, and we're always going to have a way to monitor everything that happens and roll back if we don't like it. So my first comment on the data team is just is not only the case, it's not only important when you have like one data team and you grow this data team kind of like hypertrophically, but it's more like when your data team is kind of like already big enough and still is a bottleneck, and you want like other teams who are afferent to the central team to be able to now work independently. Having said that,
And Zero, the context here is mainly around lakes and analytics, and so
that's what
so
we do.
so
Yeah,
if
that's what we
if
do.
people are building pipelines, they can have each a fork or copy of the data, and then they can safely kind of work
So
work on their pipeline. It's not like a transactional system where you worry about people overwriting the data, right? So
easy though. That's the point. Easy not though.
yeah,
That's really the point. So
yeah,
okay, so the
yeah.
transactional is an interesting angle. So in
Yeah.
the transactional database world, obviously we all talk about like concurrency because the main problem is that there's going to be a lot of different writers and
Mhm.
readers at the same time. And what you say is like, well, in the lake, this is like less of a problem because, like it's slower, it's analytics, you don't have too many people doing the thing at the same time. That is true. However, there's a trade-off between something that is like absolutely transactional and something that is effectively impossible to debug when things go wrong because the system is too fragmented and stuff breaks in 10 different places. And I think that the more we want analytics to become like part of our everyday life as people who build products, software products, the more you want to kind of like make sure that your lake is as transactional as possible, right? There's really no harm in having the lake like transactional at that point, and you have like open formats today, which I think is the big innovation in kind of like in the Lakehouse, side of things of the past years that provide you this kind of like primitive elements like built-in time travel and ACID transaction atomicity at least at the level of the table. So for us, the question was, provided now I can piggyback on the fact that stuff like Iceberg allow me to travel back and forth in time, and that allows me to consider like a table as one, like write a table atomically. But when I work as a data engineer in a lake, I actually think in pipelines. And so what would it take to make sure that my lake now is kind of like transactional when it comes to pipelines? When I run a pipeline, I know that that pipeline might change 100 tables. how do I make sure that when I kind of like in our system, I speak like in kind of like
Mhm.
Bauplan terms now, when I merge a data pipeline, that is an atomic merge, that like all those 100 tables will be updated or not. Like there is not going to be like an intermediate state where your lake is inconsistent, right? The more
And
your pipelines,
what you're describing is already happening because you guys have already used it,
this
right?
this is what like the platform today guarantees effectively that your lake is never incoherent. Like it's always transactional. And our clients use basically this built-in transactionality to do a number of things that mostly have to do with data transformation. One thing that we see often is using these primitives of the platform to do things like write, audit, publish, which is kind of like blue-green development in data. It's just a way for you to make sure that when you write data into your lake, that data is vetted and is not like
Yeah, yeah. Actually,
you don't risk
this
it.
is a very powerful
Yeah.
concept, listeners. I mean, because basically in the age of agents, this becomes almost like a must-have.
That brings like the second point because like I think like the when you think of something like write, audit, publish, right? So that is a term that refers mostly to data ingestion, and it's just a different terminology compared to the one in software. But people in data systems have been doing this like forever. It's not a new thing. This term comes from a certain talk and from Netflix and by Netflix and so on. But obviously people like already had this problem of not pouring data directly into their production system. But it's very limited to that specific like kind of like operational envelope. And the question there becomes like, well, but why only there? Why isn't this the de facto way in which your platform works? Why limit ourselves to this moment when we ingest data? Every operation on your lake should work that way. Every operation should be isolation of the data, run a transactional job, which can be a pipeline or a single operation, and then atomically merge if it makes sense to do it, or keep the branch open for a system to debug, for you to look what happened to for you to roll back and so on. Like every operation in your lake should be like that. And when you now like bring the agents into, which I think like right now is a very, I think like people are still starting to think about this, but like it's not really like I don't think people understand to the full extent how much of this is going to be a problem.
Yeah, 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 yeah.
But like if you now have an agent, you're thinking about a system where now I might have an enormous number of artificial systems working together in the same on the same pool of data, even in my lake. So now I am kind of going towards that problem that you have in transactional systems. You have a lot of systems that are reading and writing at the same time. So what do we do now? Your lake is not a database. Nowhere, there's no transactionality anywhere to be found. So how are we going to work with that? And if you buy into the concept that, 5 years, 10 years from now, you're going to have one data engineer and 300 agents that data engineer manages, this is going to be a gigantic problem. And the only way you can deal with that is you need your data lake to effectively be transactional.
By the way, so everything you've said kind of automatically explains my second question there. Because when you talk about Git for data, it's obviously
Yeah.
this is a much more, I guess, fleshed out way of thinking about version controlling your data, right? So in the earlier systems around DVC seemed like
I mean,
around,
the early system, like I think, like
it
so.
was
Look,
more
like
like I have data, I will make a copy, right? So,
look, it's
yeah,
like so. I think it started as a loose metaphor,
yeah,
right? And like the metaphor obviously breaks down when you really look into that because like data is not code,
yeah,
and there's not like we can talk about Git for data
yeah.
and push this metaphor just because it kind of like leverages the fact that people are already very familiar with systems like Git, but it's not the same thing. And so you can think of Git for data like I think like my main point is having a system that can version the data is great, and it's a necessary condition. It ain't sufficient, though.
It's not sufficient. Yeah.
Like to really have like to bring like kind of transactionality, because I keep saying transactionality, but to be very fair, our at the point where we are, I think is kind of like pseudo transactional. Like there's still differences between like transactionality in a vertical system and what we achieved in Bauplan, but it's the closest thing you have in a lake. To achieve that, you need two more things. One, a way to version your tables, but to version multiple tables. A good example of that would be a project like Project Nessie by the folks at Dremio, right? So that allows you now to think in branches and not only single tables, right? The last piece, though, is the runtime. Because if the runtime doesn't know this and the data doesn't have a way to communicate this to the runtime, there's no way that I can run a pipeline in a transactional way, because like the pipeline can still break halfway through and each of the tables is atomically okay. But now when I look at the lake as a whole, I have the first, let's say you have like a 4-node pipeline, two nodes run and then it breaks. Now I have 4 tables, 2 of them are in a new state and 2 of them are not. No table is broken. The system will keep working, but the numbers will be wrong.
Yeah.
Right? So if the runtime is not tied to this abstraction of multiple table versioning, I cannot make sure that I run this pipeline as a one single transactional job over which I will make a decision that is, it went well, all 4 tables can update now. It didn't go well, none of them will be updated. I'm going to keep this branch open. The underlying system will remain in a previous state. So the lake is going to be not updated, but it's not going to be incoherent. I think that's the key point. So yeah, so that's why I think like our...
And actually, people are talking about agents, right? So what you described there, agents could be running these pipelines right and left. And people might already be building agents to do these pipelines, but they haven't thought through all of the things that you have, right? So,
there's...
around by
Yeah.
which allows me to segue to one of your other core principles, which is some notion of safety, right? So
Yeah, absolutely. Like
reliability and safety, right? So,
exactly. So like this system is designed for essentially put you in a situation where no mistake cannot be undone. That is a very important concept. Like the problem that we solve with this concept today for my clients,
which is, by the way, this is all going to be essential for automation.
So like as of today, we basically allow people to not waste most of their time debugging. Like the problem that we solve here is just like give folks a system that is very simple to operate, and at the same time it's very, very robust. So all our clients are clients that don't have the mental bandwidth to take care of, pipeline failing anymore. Like either because there's too many pipelines and the system is too brittle, or because their teams are too small and they don't want to spend order engineering hours like that. So the core value proposition here is with very few data engineers, you can take care of a very complicated system that at this point is engineered in a way that doesn't break and leave you with a problem of solving whatever it broke. When it comes to now having like automation in place, which is something that we just started seeing this quarter. So like this quarter, we saw for the first time our agents, because we've released the MCP server, and the MCP server has been picked up by our users quite quickly. And so they started just like, using Claude Code to just like talk with the platform. Now, the important difference here is that they're starting using now Claude, the MCP, and this existing kind of like Git for data abstraction to do something that we never seen before, that is actual data engineering. And by actual data engineering, I mean, they ask the agent to write. some data into the lake.
Can
It's
you
very, very different
can
from
you
what I've
explain
seen.
can you explain, Ciro, the significance of the MCP server for making this happen?
So the MCP server is really like an enabler here. Like it's the translation layer between a coding agent and our platform. So designing a good MCP server was crucial in kind of like bringing this to fruition. I would say that not a lot hinges on the MCP server per se from an engineering perspective, because like the real point is the underlying platform that the MCP server allows you to talk to built in a way that you can use an agent to do something on your data and sleep at night effectively. It's a very simple, like if you think about this, like it's a very simple concept. It's just, if you think of Cloud Code, for instance, or whatever coding agent, 99.9% of use cases for that is code generation, right? So you have like folks just like using that in their IDE. Now, why are we comfortable with having Claude writing our code? Because we can roll back. So nobody in his right mind will allow that agent to do something on our data lake because we can't roll back. So if you introduce the same safety.
By the way, has this need to roll back happened with one of your customers? An actual need to roll back? Yeah.
The data?
Yeah, yeah, yeah.
On a daily basis. Yeah.
Yeah. So
Yeah.
it's really saved them.
Like I would say that more than rolling back is the branches, is the fact that like whenever there's something that breaks in the system will just like create this branch where it freezes in time what broke and prevents the computation to go on and change data underlying.
Wasn't there a story around Replit? Someone used Replit and wiped out a database. I forget the detail.
There's a bunch of them like on Twitter. Yes, totally. But again, like sure, you should use Git. That's like the short
Yeah.
answer to that problem is if you just had a branch,
Yeah.
that would not happen.
So has this kind of disaster been prevented in your platform?
No, I don't think so, because like right now, like I mean, yes, but not.
It's not something
Like
you would know because they would
but
just.
exactly, like you don't really have to do it yourself, you know.
Yeah,
It's
yeah.
like the Bauplan will create the branches anyhow.
All right.
Anytime you do Bauplan run, the system will run a pipeline for you, but that creates a branch. And if that runs breaks for whatever reason, nobody's going to write back into your data lake. So if in that pipeline, there's some code that either you or an agent says drop table, that doesn't go immediately into your production system. You know what I'm saying? Like you will have to double check.
So when I say safety, what other things would you like to highlight?
So I think like one thing that people don't realize is that, okay, so there's a lot of stuff that happens around governance that has to do with safety. And governance is a very broad and complicated topic. But one thing that people don't realize is that if you fix concurrency, you kind of have governance for free. And we know that because there is at least one case in which humanity figured it out, and it's once again databases. Like governance in databases is relatively it's a fairly understood thing, right?
Yeah.
And it's relatively easier. It's definitely easier than governance on a data lake.
Right.
Because concurrency is fixed, because it's a transactional system. Once you have a system that is able to really isolate like all the different writers and readers in a principled way, then the access control, it kind of comes naturally. Like it's not that hard to build that layer. And I think like a lot of what is happening, you see like, for instance, in systems like Databricks, I think like most of the folks I know, especially in enterprises who today like Databricks, for instance, it's because of Unity Catalog.
Right.
Because in a gigantic system, in a gigantic data lake, that is the first time that they have something that looks like, oh, I can deal with governance, right?
And by the way, another full disclosure, I'm an advisor to Databricks, so hello to our Databricks listeners
So
out there. But
I'm a fan, so
another thing that permeates everything you folks do is this notion of code first. In fact, Python, right? So,
yeah.
of course, the naive question here would be code first, Ciro. I mean, I'm just going to use prompts.
You will. You
No,
will.
no, 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 no,
But
no.
your agent won't. Your
Yeah,
agent will use code. That's the
exactly.
point.
So,
Yes.
so talk to us about this importance of why do you folks keep kind of hammering this point?
So, okay, so the point about code first is
Or everything is code, kind of.
so yeah, so the first thing is operating with Bauplan feels different than other data platforms of a previous generation. Working with Bauplan looks like working with a Python package, right? So you effectively will pip install a package, then you're going to work mostly in your IDE, and my UI can only read. When you write something, when you do something that changes the status of the lake, you always do that through code. All the functionalities of the platform, which are branching, querying, running, importing data, dropping tables, merging the branches, all that is always exposed as an API in your code as a through, like right now we have a Python client in a CLI, right? The point about that is this: UIs are great, but they're not really meant for stuff that is done at scale, and they suck for automation. And our vision has always been like this thing that the data is still so UI dependent is just an historical quirk. Like right now we do that because we do a few dashboards. But with data becoming like so important for all the systems that will embed AI everywhere, we need a way to program stuff. This is very much like when the cloud came along and DevOps switched from being kind of like a very manual process to something that you do through infra as code. It's very much the same thing. And so now when it comes down to exposing the entire platform as code, is that I can expect now AI system to manipulate that platform in a way that is native to them, because AI systems are great at coding and they're terrible at UIs. So coding also not only allows the LLM to be able to operate the system immediately, but it also allows us to have a very principled way and imperative logic on top of what the LLM does. So now I am back to my security point. So I'm back to the point that if you want an LLM to do your work, which is something that I strongly believe is going to happen, like a lot of the data engineering work will be automated. You want to have a system that is built from first principles for that workflow, which is very, very different. And so there's a lot of kind of like agent washing going on, where you have like a platform that you obviously built for a dude, and now you just like, put an agent on top of it. Because like we're an agent company, it's like, well, kind of like the problem with that is that, yeah, like the agent will require a special way of thinking about your interface and do very API first and code first design, but also because the agent will not behave like you. You will model the workflow on what you do, but when you actually look at the traces, when I look at the traces of the agents that my clients run, they kind of look like me, like, but they don't do exactly what I would do in solving the problem. So your system really needs to be kind of like redesigned in that perspective, like from scratch. I think like right now, like
Yeah, yeah.
there's a
There's a
chance that
lot.
we're kind of like at the end of a cycle. Like when Cloudera and then like the cloud came along and Snowflake came along, the saying just like, well, it's not that you couldn't do distributed system before. You could do that on, like Cloudera made a fortune out of that. But then the world changed, and now we needed a system that was built from first principle for the cloud. I think we might be at that inflection point where the previous generation has been consolidated in fabulous platforms that we all love, like Snowflake, Databricks, and so on. And now like a new brave world is coming along and you kind of have to rethink things again.
Yeah, yeah. Actually, as you were talking there, it occurred to me one of the things that I think people do too much of is anthropomorphizing these agents, right? So, you know, c- basically imagining that the agents are people and will behave like people, but they're not. And also, why
Yeah.
force the agents to use tools that are built for people? So that's why I kind of like what you guys are
Because
doing.
that's the tool we have. That's the tool,
Yeah, yeah.
those are the tools that we have right now. But we kind of have to rethink some of them like pretty fundamentally. Like I give you an example on something about like querying, for instance. Uh, if I'm a data engineer and I am on something like Snowflake and I basically pay per query, I have an incentive to think about my query, okay? And craft the query in a certain way and optimize it if I'm a good data engineer and then run the query, right? And I might not get it right, and so I will have to iterate. But I have an incentive to think hard about what I'm doing and minimize like minimizing iterations that are just silly. The agent does not work like that at all. And like what they most like what they work better if you allow them to do fast iterations over queries that are very similar and they keep fixing one line at a time or like one filter at a time and so on. So that effectively now brings us in a world where if you, again, like if you use one agent, it's fine. But if you think again, like think about the future. In the future, you're gonna have like hundreds of these guys. So now you have a system where there's a swarm of agents that keep hitting the system with suboptimal queries, and they're kind of like iterate their way to the right one. Is your system designed for that high throughput, high redundancy scenario? The answer is no, because like nobody uses warehouses like that,
Yeah, yeah,
right?
and you have to assume the scenario. You can't assume your agents are going to be
I mean,
super,
you
super
can
optimized and super smart because someone might point an agent at your system that's actually not super smart and will brute force their way through this query, right?
but I mean, because like there's a lot of considerations there. Like, sure, I can prompt my agent to be more thoughtful,
Yeah.
but ultimately, kind of pick like it kind of boils down to how much inferential capacity the agent has. And so sometimes, I don't want to use like my most expensive and fancy model. I want to use like a fairly dumb model that I might, kind of like in context learning to the point that gets good at a certain task or even fine tune in certain cases. I think fine tuning is pretty been going away,
Yeah.
but like yeah, I don't know what's gonna happen to that. But like you see what I'm saying. So if because it's an absolutely from an economical standpoint, it makes sense. Like I run an organization, I don't want to use like Claude all the time. I want to have like something cheaper, something dumber. So at that point, my best way to leverage this model is actually have the model going, in fast iteration. And I think that the way in which people think about the model will drive the rest of the infrastructure, not the other way around. Because the model is too important and they're too much of a revolution. So once we all start using the models to do most of our DevOps, most of our compute, most of our code generation, we are going to retrofit our tools to the models, not the other way around. The models will become the core of what people do when they work. And then you never like once you get people to work in a different way, it's almost it's I mean historically I have no precedence of people kind of like going back to a previous paradigm.
The other thing that you folks recently released, preprint, which I will link to in the episode notes, is around this concept of a programmable lakehouse.
It's what
So
I kind of like just described, right?
yeah, yeah, yeah. So how far along is this programmable lakehouse in terms of it's is this already does this fully describe
You're
what you
like,
do
can
now?
you use it? It's like, does it run? Yes.
Or no,
Yes, it
no.
does.
So what is on the roadmap if beyond what you described, right? So,
No, I mean, like, so I want to make very clear where we are. So Bauplan is an early stage company. So we're seed stage. So the stage where we are is our initial MVP is not generally available, but is very much in production. So we do have early clients. They kind of graduated from being design partners to be actual clients that use the product. But there's a lot of work to do to make this system a generally available platform. And mostly the reason for that is that building data infrastructure is a Herculean task, and it takes like a lot of time and engineering. Our company is being exceptionally efficient in doing that in the first years to test whether this makes sense and be very, efficient at that. And then now that we have initial validation that this way of working does resonate to a new generation of companies, because all our early customers are startups, modulo one large enterprise who bought into this vision early on, but the others are startups. So once we have early validation that this can be done, I have no doubt that a change in the paradigm will happen, because that's not on me. That's just the environment. That's just the world is changing, and I'm just like riding that wave. So yeah, so the next stage for us will be focus on making this like a fully fledged end-to-end platform. The thing, for instance, that I mentioned right a minute ago about like querying, that has enormous untapped potential that right now we really scratch the surface by designing our runtime in a certain way that isolates workflows in very small units. So it's kind of like agent friendly, and it's very easy to isolate the runtime, and we run everything as functions and so on. That's really the beginning. The next question is like, so how do we schedule them? And the next question is going to be, so how do we build a caching layer for this high redundancy thing? And the next one is going to be like, okay, so how do we make the system now fully distributed? And like, so there's a ton of work to do. But we're pretty excited about the fact that folks are using it, which is it's a curse and a bliss. Like we get like folks pinging us in the morning and going like, hey, like what about this? Like this is not working exactly as I expected, or would you guys be open to add this new feature? So the folks are really starting to be very engaged with the platform, and I'm very excited about the fact that they sort of spontaneously went into the agentic angle without being really pushed by it. Like releasing the MCP server was enough for them to kind of like figure out, which speaks volumes, I think, to the extent of how deep the way in which people work is changing. They all spend their day in Claude Code. Like I don't really have to convince them. You know what I'm saying? Like they're already doing that.
So it seems like a key component in these things that both Databricks and Snowflake and a bunch of other startups are promulgating is this notion of a semantic layer, which basically is just providing
Absolutely.
providing additional context, right? So by the way, I don't necessarily like that term, semantic layer, but
You
anyway,
don't?
no, because it's additional context. So context something. I think the
I see what you mean.
Dexter folks call it context store, right? So something.
Right. Okay, that's actually, you know what? I like that a lot, because I think like it gets even better.
The semantic layer,
I like that a lot
there's
because
the semantic web people. I don't know, man. So
Oh, I see. Okay.
so
Okay, that's
anyway,
a
so
late 90s reference. But like now I get like, so I like that a lot because I think like the emphasis on the context will be like even better now that we think about like AI systems interacting with this.
yeah,
Because like it's going to be, I think like going forward, forward is more, it's even more about providing really the context and not just the definition of a metric.
yeah,
Because the agent will have to pick that. Like there's more things that the agent can know than just the formal definition of a certain metric, just because the agent kind of speaks English because it's good at predicting the next word, basically.
So
I like that a lot.
is this part of what you folks are providing?
No. So okay, so Bauplan is effectively an infrastructure company. So what we want to build here is the next gen data stack that is built, from first principles for AI systems to operate the compute and the data management layer. Okay. So that is really what we want to do here is kind of do like
But
the
you
next
have a you
the
have
next Databricks, but for agents, right?
you have an MCP server. You might as well provide the agent's context.
Fair enough. So having said that,
Yeah.
I think that semantic layer is very important in the way in
Context
which
store, you mean?
context store. Fair, right.
Yeah.
The context store
Yeah.
is very important in the way in which the customers and the users ultimately will operationalize their use cases. So, am I selling a context, a semantic layer? No, and not right now. And I think that there's a lot of cool stuff that will happen that I can just tap into.
Right.
I'm okay with folks bringing their own way of defining their context and their semantics. Also, because I think that it's very unclear how that will happen. Traditionally,
Yeah,
your
there's no consensus. There's no consensus.
there's no consensus. Like traditionally,
Yeah.
the semantics is defined inside of your BI tool, right? Which sucks for so many reasons because now you have like this thing is it's a silo and nobody can really tap into that. So and then there's like the second phase, like lately more companies like cube.dev, for instance, like came along saying just like you should make your semantics independent from where you write your queries, which is obviously a good idea. And now I don't
Yeah, I
know.
don't know if you remember, there was the generation of metadata startups like Metaphor.
Yeah,
They had basically that, but they stored it in knowledge graphs.
that is correct. Yeah, exactly. So like extrapolating that from your consumption layer, I think is obviously a good idea. It's a good design choice that will pay off 100 folds when it comes to then when you want to standardize things and want to shift left
Yeah,
and
because
really like
you
bring
might have
engineers.
multiple systems. You might be running
Yeah,
Bauplan, Databricks, and Snowflake all in the
exactly.
same company, right? So,
Exactly. And I'm really interested in that because this transition that I'm talking about will not happen overnight. And I am under no illusion that previous platforms will just go away. If you walk in any big American bank, you will still find IBM mainframes, right? And that makes sense. Like systems are there to stay, but some workflows will migrate to more different platforms, and we hope to be one of them. But I think like composability of your system as of 2025 is a very important thing. So I'm not terribly interested in locking you into my semantic layer. I kind of like I
but
also went through
you
that as a user, and it really I did
but
really
you envision
appreciate
a
that.
scenario where you will take advantage of some sort of context or semantic layer.
Oh yeah, no, we already are.
Yeah.
Like, don't get me wrong. Like, we're already like one thing, for instance, that is very cool is that Iceberg will provide you the possibility of actually propagate your metadata and put a lot of context in that metadata onto your system, which is something that we plan on capture. So you can have like your semantics already defined in your tables. But it's unclear what is going to happen there. So like, there's no player that I can like. There's no clear choice that people go to. So like I don't know, like I don't have an integration to build just yet. That's I guess what's what I'm trying to say. But I think it's a very important point because like like all the projects that I see today in kind of a chat with your data type of thing will fail miserably if you don't fix that. Because like lowering the bar is important. Like if you get like people not to, people that absolutely don't know SQL and never will be able to talk to the data is great. But if you don't control that layer, you risk to have folks now to kind of like use an LLM as an oracle. And there's no way you can know like whether the data is right or wrong, the numbers are right or wrong. Like who knows? So it becomes like very important to actually have to bring those projects to success. There's our largest customer is actually very interested in that because they work with Looker, and I think like just again like it's one of those generational shifts. They got I think like, to the point where they're a bit worried about so much semantics being expressed into this special language that only Looker speaks. So yeah.
So I guess let's start winding this down. But one other thing that's come to mind is, when you talk about data engineering, pipelines, We also have now all these tools for orchestration that people have
Yep.
gotten used to, right? So Airflow, Dagster,
Mhm.
Prefect, whatever, right? So those tend to use static DAGs. So what
Fair enough.
is there anything around orchestration that you want to emphasize that may need to be reimagined, revisited?
So we deal more like because we effectively run your pipelines for you. So like
You don't need any of these tools.
no, it's not that I don't need that. Like it's just like in the hierarchy of things, we are more similar to a warehouse. Like we're actually the runtime as opposed to the orchestration. So I spend more time thinking about orchestration as in how do I schedule my jobs in a way that optimizes a certain, workflow, a certain
Yeah,
run
yeah.
of a certain
Orchestration is
job.
like scheduling,
But as
monitoring.
orchestrator as the really kind of like outmost layer, as in monitoring or um, yeah, scheduling, retrying, and so on. I don't spend a lot of time like thinking about those problems these days. We do integrate with all of them. So all our clients do have orchestration in place, and it's just higher up in the hierarchy than us. So you have like an Airflow or a prefect or a temporal task, and that task will call a Bauplan run, and then Bauplan will run that pipeline for you, or import the data, or create a brand. Like it will call an API that will do an operation with Bauplan. So I don't know. I
So in
see that
your
there's a lot of
intuition,
interest.
does your intuition say that these tools need to be reimagined for agents?
My intuition says that these tools need to be like that. Some of these tools will need to be reimagined, and I have a soft spot for the folks at DBOS or
Oh yeah, yeah, yeah.
DBOS,
Deep, yeah,
right?
yeah.
Right. I like a lot of the simplicity that they bring to this kind of like durable function world. I think temporal is also like a very good platform to do that. It's a bit more complex but probably kind of like more suitable for enterprises. So that is something that I think like will be interesting when it comes to bringing agentic workflows, because that is needed. But I also think that the big takeaway for me is that simplicity wins. So your orchestration layer should not be your runtime. That's really what we care about at Bauplan. It's just like I've seen so many data infrastructure projects kind of like going bananas because you end up having this massive Airflow projects or where you crammed both like your the transformation logic inside of your orchestration logic, and now you're kind of like locked into that. This is another thing that people often don't think about um, long enough. That is, some of the lock-ins are not about a vendor. Some of the lock-ins that you're going to lock yourself inside of a tool of your choice, and you're never going to get out. So sure, you can download from the internet an orchestrator, but the problem is that if you're going to start writing your entire business logic inside of that without a separation of concerns like orchestration, then runtime, then data management, um, you're going to die in that orchestrator. Like there's no, it's like quicksand. You're never going to get out of that, and it has nothing to do with a vendor locking you in. It's just like now at a certain point you kind of like design this entire system to be, it's going to be a migration. It's kind of impossible to get out of that.
So this is an impossible question to close with, but in 5 years, how do you think the role of the data engineering team or the data engineering persona evolves?
So if we're right, so we were right about a lot of things. Actually, we're more right today than we were when we started.
And
So
stop you there. So for our listeners, when I first talked to Ciro, I kind of got what they were talking about, but I didn't really get it completely. So proceed.
which, which might be my fault, man. But, but yeah,
No, no,
so
because a lot of things now make sense with agents, right? So
you see what I'm saying? Like, kind of like we were right. It's just that
But yeah,
the
when we talk,
workflow was not there.
yeah, when we
Yeah.
talk, there were no agents, so it was,
There
yeah,
were no agents. So like all these things like sounded just like, oh, this is just like cool design principles.
yeah,
And
yeah,
now they will become vital,
yeah.
essentially. And so if I am right, I would expect the work of a data engineer. So I would expect the spending on compute for data to grow and the size of your data engineering team to shrink. So I would expect to have the possibility of a data engineer to be able to do 10x the work that it's doing today, offloading a lot of the repetitive and hard, it's kind of like hard work around like debugging, root cause analysis, link fixing, and so on onto AI systems. That would be like my bet. My bet would be that yeah, the
So
work of a data engineer is kind of like orchestrating a lot of AI systems and keep really the most important questions for the human about how do I architect this. And in my wildest dream, data engineers will end up being like more closely related to the business. So understand also now the why, because that's a big problem with data engineering. Like because it's so complicated, you get fixated on the infrastructure and you kind of like lose track of why we're doing this. Yeah.
Hey, by the way, so that's actually another thing that we didn't quite talk about, but a lot of what you do also makes the incident response and root cause analysis a little more.
Oh, that's just because like the beauty of that is that I think so to automate the work of a data engineer for real, you will need your agents to write. That's a fundamental thing to understand. If you only need your agent to read, so to go look at the data, explore the data, and come back to you with something without changing anything in your data lake, you will be able to automate what an analyst does, a lot of that workflow, and the root cause analysis. So you will be able to ask your agents like, oh, this pipeline broke. What went wrong? Come back to me with a report and tell me what you think I should do. That's fantastic. And to be frank with you, we already have like 2 customers using that today. Okay. What I'm more interested in is the next step. Once you come back to this, like, these are the next step according to you, my agent friend, why don't you go do it? Why don't you go fix this thing? And then come back to me with a branch and a PR and tell me just like, this is what I did and what do you think about it before I merge it? Because that is a whole different ballgame. That's really automation. But to do that, the agent now has to write. And if the agent has to write, you need a way to trust the agent, which is it really depends on how the system is architected. And if the system is architected to provide isolation and this kind of like Git for data way of doing things, the agent can go do something. Worst case scenario, there's a branch, we can roll back, we have a commit history, we know what happened. If you don't have these pieces in place, I understand that having an agent writing in your data lake might be too unnerving.
And with that, thank you, Ciro.
Well, thank you very much, Ben.